A live hack session today on Talos. Welcome everyone. My name is Andrei Smirnov and I'm engineering lead at Cedar Labs, and today I'm going to try to fix a bug in Talos and show how to do Talos development, how to reproduce the bug, how to do a fix, how to build a new version of Talos, how to test the fix. And just let me confirm that everything is working. Yeah, let's see. It seems to be good. So I'm going to share my screen and let me post an announcement to the channel. Okay, should be good. So we're going to hack on Talos, and most of the things, the flows, how to prepare your environment, we have that in the Talos documentation, so you can find it there. Talos build process requires just having Docker buildx, what is build kit based, which is now standard part of Docker distribution. And all the build is happening within the container, so you don't need to install anything on your system to build Talos. But I'm going to test some things which require running Talos in a virtual machine. And the flow we have, which is fully automated in Talos using Talos CTL, that requires running it on Linux. There we have a full flow which sets up networking and boot Talos with all kind of various features, and we can interact with Kimo. And we'll see. So the issue I'm going to fix is the one I saw once on Google Cloud, and I think it's not specific to Google Cloud, but when I was trying to shut down a virtual machine with Talos, and the virtual machine was running at that moment in maintenance mode, what I saw in the console that Talos received the ACPI event. That's what it gets from the hypervisor when you try to power off a virtual machine in GCP. But it actually failed to shut down itself. It said that failed to acquire the log timeout, which I think is part of the like internals of Talos we'll get into. And that's clearly a bug, because if Talos doesn't shut down itself, the hypervisor will wait for some time for the VM to shut down itself, and if it doesn't, it will just simply power off that. So we need to fix that to make sure that shutdown is graceful, everything is synced to disk, and so on. So the first thing to do, we need to try to reproduce this behavior with the, I want to reproduce that with the local cluster running in Kimo, because this way I can quickly try to develop a fix, test it, and see if I can get this bug fixed. Because if I will try to do this on GCP, the process will be way slower. I will have to build images for GCP, upload them, run Talos from that image. Just way too slow. So I'm going to do this in local mode instead. So I have the terminal here, which I'm going to use. It's in the Talos checkout. I'm now on the main branch. What I did, I built all the components required to work on Talos. I'm building the initramfs and the kernel. Kernel is not built, it's just the already pre-built image which is being pulled. And I also built Talos CTL to make sure that it's in sync. So it's just the Talos version from main right now. I'm going to try to create a cluster from it running in Kimo on my local machine. So I'm going to do a cluster create command, and I should have one in my history, which will work. That's pretty much standard command. There's nothing really interesting about that. I'm using registry mirrors locally, which are also documented in Talos docs, which allow me to speed up the image pulling process. And as my bug can happen on both control plane and workers, I can use either of these to test it. But I would prefer to use a worker node because it's much faster to shut down a worker node than a control plane. It just has less things running on it. So I'll start with a single control plane and a single worker just for me to make sure that it's easier to test. And in my line, I have the bootloader disabled, which means that each time Talos boots, it will actually not boot from the disk of the virtual machine, but rather it would boot kind of over the network as if it was the network. But it will actually build from the initramfs image that I have built locally. So if I make a change to Talos code, I rebuild initramfs and I reboot my node, I get like new version of Talos running immediately, so I don't have to go through the install process once again. It's kind of as if I was network booting it all the time. That speeds up the process. That's also described in the docs. So I'm going to hit enter, and Talos CTL cluster create is going to use Kimu and some networking plugins to set up a bridge on my local machine. And we'll create VMs, connect them to that bridge so that these VMs can talk to each other. They'll have their own private IPs assigned. And also, these VMs can talk out to the public internet. And that's like a perfect simulation of the real cluster network, I would say. Okay, so right now we're waiting for the Talos API. So we're waiting for the nodes to boot up. I actually booted up. And you see that Talos CTL is automatically bootstrapping the cluster. There is a lot of magic built in Talos CTL cluster create to make the initial flow easier. It bootstrapped the cluster, did some initial checks, and now waiting for the nodes to finish the boot sequence. It will do all kinds of health checks to make sure that my local cluster is healthy and it's fully booted. So I can just simply sit back and wait, or if I decide to, I can not wait. So the way I booted up my cluster right now is that it actually runs in not in maintenance mode, but in normal mode. Maintenance mode in Talos means that there is no machine configuration, and Talos is waiting for machine configuration to be submitted. Well, like normal mode is when running with the machine config. The way I launch Talos by default, Talos CL cluster create will generate machine config and provide it to each node. So right now it's booting up in normal mode. I'll see if I can reproduce the bug in normal mode, or first of all, does it even work in normal mode? And then I will try to find the reproduction for this case. And once I'll figure out how to reproduce that, I can move forward. So I can split my terminal, and to make it more fun, I can also look into the logs of Talos, so to see what's going on. These are the console logs for each node. You can see the health checks are actually moving forward. We have one node, which was the control plane. It booted up fully. The worker is still booting. And I can see the last error actually is node not ready, which means that CNI is coming up. The next thing I need to do is to figure out how to do this ACPI shutdown event, which is actually the same event the machine is getting if you push the power button. It kind of just says, please do a graceful shutdown. And if you push that button down for a long time, it will power off the machine completely, but it tries to do a graceful shutdown first. So in my case, Talos is running in Kimo, and I can verify that. I can show that we have some QEMU processes. These are two processes for each VM running here. And I can use what is called in QEMU like a monitor to interact with the QEMU itself. So I can make QEMU send this shutdown event to the machine. So for that, I need to find the socket. Here is the monitor socket. I'm going to use the worker as the first node. So we have this socket, and I can, that's a file socket technically, and I can use socat to talk to this socket. So I can connect to the worker one, and I can do something like help, and it will show me that I'm interacting with QEMU. It shows all kinds of commands available in QEMU. And there is a system power down command. I have no idea what it does, but hopefully it does what we're looking for. Let's try this out. Okay, that was quick. And let me scroll back the logs. And you can see shutdown via ACPI received, and that's should be exactly the same log message that we saw in the issue, right? It's here. But this time it worked. It worked like I expected. Where is that? Here it is. It worked as expected. It ran the shutdown sequence and shut down the kubelet, all the pods running on the node, like unmounted everything, so on. And in the end, it goes into the system hold state, which is it should have powered it off, but that's a bit of a small detail when running in QEMU. Instead of like real power off, we actually do hold, but that's enough for me to reproduce. So I know when the node is running in normal mode, it's doing fine. So I need to reproduce this issue in some other mode. First of all, let's bring the node back up. To do that, I'm going to tell QEMU quit command so that it actually aborts and Talos CTL will restart the VM. So I'm doing quit, Talos CTL restarts, and I'm back in the monitor for the new VM. And I'm going to try to do this before it finishes the boot. I did system power down while it's still running, and it seems to be not clean, but proceeding. So here I have the shutdown received, and I can see that initialize sequence, which was running, was aborted, and instead we have a shutdown sequence running. And there are some error messages here. Destroy finalizer rate limited. Context cancelled. Interesting. We need to probably look into that, but that's not exactly the error I was looking for. But we also had a not completely clean shutdown. Sorry, the logs scrolled down a bit. So let me scroll back to the moment where we had the issue. I hope you can see that as well. But scroll back, scrolling back, scrolling back. Yeah, so the shutdown sequence failed, which actually caused Talos to enter like a panic mode, and it tries to reboot. But at least in this reboot mode, it unmounts everything, syncs the disk. It reboots instead of shutting down, which is also bad, but not as bad. Well, I don't know. Probably it's same bad because after reboot it will go back up. Okay, so far I wasn't successful to reproduce the issue exactly, but at least I have something I should work on. So what I'm going to do, I will copy paste these logs because that's all I have about this problem, and put them to the editor so I can get back to that later. I'll just create I'll close everything I have, create a new empty file and just copy paste the logs so I can get back to that. Okay, let me try to reproduce the issue once again. But this time I will try to make it as close as it was in the issue. I'm going to destroy the cluster I had. And I'll try to put it to maintenance mode. To put it to maintenance mode, I need to tell Talos CTL to stop generating the machine config and making it available to the node so that instead the node boots, it has no machine config and it will just sit in this maintenance mode. So the easiest one is to say skip injecting config to Talos CTL, which will tell it to stop doing that. So let me try this. If I do that, the nodes are booting now. But if I did that right, it should sit in the maintenance mode. Yes, so now I have my nodes. They're in maintenance mode right now. That's the message Talos prints when it's maintenance mode. It waits for the config to be applied. So it says apply the config to a node. I'm not going to apply the config. Talos TL is still waiting for the API to come up. No, it won't come up. It's in maintenance mode. There will be no real Talos API. So instead, I'm going to cancel that and go back to my QEMU monitor and send this system shutdown event here. Let's see what happens. Okay, I typed it wrong. System power down, not shutdown. Okay, system power down. And it works once again. That's the worst, but it happens. It looks like we have a different error this time, by the way, which is interesting. I'm going to abort here, but we have another set of errors, not the one I saw, which I suspect got fixed in Talos, but we have a different set of errors here, and they still need to be fixed because our goal is to make sure that Talos shuts down always, right? So I'm going to copy paste the logs here as well, so I can have something I can trace down to the bug, and we can analyze them. Okay, that's one set of logs and another set of logs. Close these so I have more space to look into the logs. So what happened here? What happened here? Well, I probably missed one line of the logs. Let me get back and copy a bit more. Oh no, I think it's... I don't see the shutdown message at all. Okay, let me check. I'm looking for this shutdown. Well, let me look for ACPI in the logs. Yeah, it doesn't look like it's here, which is interesting, by the way. I don't see that message. Oh, come on. I think our message has... No, it's there. I probably missed that. Okay. Let me look at the worker log once again and look for that specific message. Okay, I can't find it now, which is interesting. Oh, because I'm probably looking in the wrong one. I was looking in the control plane, not a worker. Okay, probably the output was like misleading when you tail it, but when you look at the log, it looks to be correct. So that is the time I sent the ACPI shutdown. Talos was sitting in maintenance mode. For Talos, it means it was sitting in this load config task, which says fail to receive config using the maintenance mode. It was canceled, fine. And instead, the shutdown sequence gets called, which is completely fine. It tries to stop the kubelet, which it can do. It makes sense. It doesn't run in maintenance mode. But then it tries to connect to the CRI, which is the containerd interface for the kubelet. And it can do that because there is no CRI either. In maintenance mode, there is nothing running at all. And there, the shutdown sequence just fails hard. It says, okay, I can't do anything. And instead of shutting down, it reboots. So probably we need to fix that as well. Let's try to trace this down. We know that happened in the task, which is called stop all pods. So we can look into this task first. So let me go back to the editor. And I know that in Talos, all tasks like that, the sequencer tasks, are in the file which is called v1 alpha1 sequencer tasks. And I can simply look for this label, stop all pods. And here it is. That's the task stop all pods, which calls actually stop and remove all pods function, which is obviously doing all kind of hard work. Here, the first thing is wait for kubelet lifecycle finalizers, which is basically waiting uh, for things which depend on the kubelet being running. That's actually the virtual IP, and where we don't have kubelet running, so this thing actually succeeds. Then we try to shut down the kubelet using like dbus, that's the channel kubelet is waiting on. And that apparently succeeds. And then we create this CRI client here. And we try to remove the pods. And we create it unconditionally. We don't check for anything. We don't check that CRI is running or something like that. We just create it and try to do things, right? And what if CRI that isn't running? We can't like do that really. So let's take a look down into the code. It says that it creates the contacts and it does like a blocking attempt to connect. It fails on non-temporary dial error, which might be our case. And we're connecting to the endpoint, which is specified above. And that endpoint is the containerd address, which makes sense. And I suspect that this call fails here. And once it fails, this aborts, that fails this task and aborts the whole sequencer. So that's our problem right now. So let's see what we can do about that. Error connecting to CRI. We can actually try to find that error message just to be sure that it's that. Error connecting to CRI. And yes, it's coming from the package that I was looking at. Exactly, so it fails here at this exact place. Okay, so next thing is how should we work around that? How should we deal with that? The actual message is context deadline exceeded, which is like not really helpful. It just means it tried and failed. And actually we can see it's the timeout we saw in the code. I don't know if you saw that. Was it 10-second timeout to connect? And this message, the previous is printed at 52 seconds past the boot time, and the next one is 62 seconds. So exactly 10 seconds between them before it fails. So it tries for 10 seconds to connect, it fails and aborts. So if I look at the error itself, context deadline exceeded, it doesn't give me much information whether like CRI is running, not running, what is going on actually. So I have two ways in Talos to figure out what's going on. First, I can look whether the CRI service, which runs the containerd, whether that service is running. And if it's not running, I can skip. Or I can also look at the file, which is the actual file socket that I use to connect to the API. And if that file doesn't exist, probably I can skip this. So let's explore these two options and see what might be the best one here. So the container D address, right, is on /run /containerd. That's where we put it. And I'm trying to figure out whether /run is in memory or that is on /var. If it's in memory, I can use the fact that it doesn't exist as a fact that CRI is not running because it gets cleared on every reboot. If it is on disk in /var, it will persist like over reboots, so it's like not a good sign to see whether CRI is running or not. So let's look into this, and trying to figure out where it gets mounted is a bit tricky. But we have a mount package, and inside of that we have lots of like mounts, and I can actually see that /run at least itself is a tempfs file system, so it means that it's in memory. So I can probably do a more simple check just to see if the socket exists. I can start with that at least. If it doesn't exist, there is no sense to like keep doing that because CRI is not running. Let's try that. So to test that, well, somehow CodePilot is figuring out what I'm looking for. Check that the CRI is running and the socket is available. If not, skip the rest. Not the reset, but the rest. Okay, I did some changes. And what I can do now, I can test them. So let me go back to my terminal. And I'm going to build new initramfs because that's what I changed. I changed the Talos code, and the whole Talos sits in the initramfs. So I need to rebuild initramfs to get the new code. And what's going right now with my VMs? They're still in maintenance mode. The one which failed to shut down, it rebooted back. It's now running the Talos once again. And what I can do, I can force the VMs to reboot. So, and as I said in the beginning, for those like probably missed that, as nodes are booting each time, not from disk, but from my image of an initramfs as if they were booting from the network. As I updated the initramfs, and if I reboot the nodes, they will pick up the new code with my changes. So let me do that. I can use, I have somewhere in my history like a quick command. It's also in the docs to reboot every node. I'm basically sending quit command to Kimu, and it forces Kimu to restart. It will pick up my new initramfs image. And what I can also do, I can verify that it is running. And I can also verify that it picked up my latest image. Oh, yeah, tail is a bit of a mess, but I can use less to look into logs for a single machine. So if we Talos when it boots early in the boot sequence, let me find that. It prints a message. Yeah, it's here. Booting Talos, blah, blah, blah version. And this is the version that got embedded into the initramfs during the build. And when I started doing my changes, I had a clean version, which was with the like clean git checkout. And as I did my changes, now my git checkout is not clean. In other ways, dirty. And I can see that the version here is also a dirty one, which means, yeah, it successfully picked up my changes. So I have it running in maintenance mode now. And I can repeat my test. So I can connect to the worker one socket and do a system power down. Okay, interesting. Now we have something new. We see that stop all pods task now successfully finished. It basically skipped that part, but we have an issue with the next task, which is stop T-bus, which basically just panicked. And we have a trace back. Well, we had a trace back before. We had a trace back, but we had more logs. As the node rebooted, let me get back to less and get back to panic. Here is the panic message, so we can use that to figure out what went wrong. That's the go panic with the go traceback. We know it was segment violation with the address of 0, it looks like. And that happened in the file v1 alpha 1 dbus at line 58. So what I'm usually doing, I'm just going there in that file and looking what's there on that line to see if I can just guess what's going on. Okay, on this line 58, we're calling dbus cancel, and dbus is something which should be like initialized. I believe we had a PR which fixed that. I think I saw that problem already. I think we fixed that, but looks like it's not fixed. I'm confused. To blame that. Oh, here it is. That's the fix 3 weeks ago, but in a different method. But not here really. So what we might be experiencing here, it looks like that the cancel is probably nil. And we're trying to call that, and that causes panic. So basically, we're calling a stop without calling a start. And like dbus, this is really a mock. Talos doesn't have a real dbus. Okay, I can now see comments. Sorry, I haven't seen them. The letters are too small to read. I'm not sure which one. I can make them even bigger. I'll try to hurt a bit of the viewing field, but let me. And we have a question. Is device initialized if you're in maintenance mode? Yes, it's not initialized. So this device is really a mock. It's not a real implementation, but it's the only way to tell the kubelet to do a graceful shutdown. So we're providing that mock to the kubelet only to tell it, please shut down now, so that the kubelet starts shutting down all the workload pods. And then it tells us when it successfully did that, and we can proceed with stopping the kubelet. So it allows us to do the proper shutdown sequence. In maintenance mode, there's no kubelet, there's no debus. In fact, almost nothing is initialized. In maintenance mode, even there is no like disk. Talos is not installed. In fact, it's not installed like in my testing environment. It could be installed, could be not. But really, there is nothing there. And there's no debus, but we're calling this debus stop anyways, right? And let's see where it got called from. Probably there might be some information to that. So we'll follow this trace back. And we know that happened in this v1 alpha 1 sequencer task, line 2348. That file is too big to be handled, I would say. Okay, here it is. have this stop dbus, which gets called unconditionally, basically, right? There is no condition here. We start dbus, which happens somewhere in the sequencer, right? But when we stop it, we just stop it. There is nothing here, and so I think we need to make sure it got initialized, and we can see that this cancel gets initialized in the start function. So we can probably do some kind of a check to make sure that if it's not initialized, there is nothing for us to do. We can do if dbus cancel is nil, we just return nil early. We can terminate. And to make sure that I'm just looking if there might be more to that. Can do a check at least here. That if the login, demock, and broker that are basically interfaces to the kubelet, still if they're not initialized, we can just abort early. There's nothing we can clean up. But anyways, we have some changes, and let's test them. When I'm saying let's test them, I mean let's test them in maintenance mode first, because as I'm making my changes and I'm testing them only in maintenance mode, that doesn't make much sense, because I'm not doing like a full test. I'm only doing like a partial test. What if I broke the actual like normal mode of Talos and it doesn't shut down properly now? So I should test both. But first, I'm trying to focus to get the fixes in to make sure that I can shut down in maintenance mode cleanly, and that will probably discover issues in general because nothing is running in maintenance mode. It's kind of the worst case scenario in some ways. So I have new NitramFS. I'm going to reboot my nodes. I'm going to tail the logs so I can see when they're back up. You see this flow is like pretty quick. Talos boots up in like less than 10 seconds probably. I saw the messages, they were scrolling really quick, but it's now in maintenance mode. So I can go directly to my Chemo monitor and try to send power down once again. Okay, more panics, which is nice. We're moving forward. So now stop dbus task we were looking into this time. It successfully finished. It did nothing. Then we got into the stop services task, which finished the only service running by that time, which is UDFD. Then we start unmount user, which means unmount user disks. And there we have a problem. Once again, we have a panic. We're trying to unmount disks somewhere here. Once again, sequencer tasks. This time line 1102. Yeah, you can see how fun it is and how many bugs are there actually. That's the unusual path, which is not tested frequently. Okay, so this is a function, helper function, which gets called from somewhere. And what it tries to do, it tries to unmount the user disks, which might be mounted using the machine config. And here it tries to access the machine config. But when we are when we are running in maintenance mode, there is no machine config whatsoever yet. So this code basically just fails. So let me go back and see where this gets called, just to make sure. Okay, it gets called from unmount user disks. But okay, why we have a function which gets called exactly once? I'm not sure. Is it really just once? Yeah. Probably that's something which has got like left over from some time, but I feel it's a bit misleading to have a function like that. So as I'm fixing that, I would try to also remove it. I will kind of bring it back here so it's a bit more readable. And I will kill this one. Okay. I have mount disks function as well. Probably makes a bit more sense here because it at least has two steps. But the other one was just one step called exactly once. Probably doesn't help. Okay, I lost that function. Here it is, unmount user disk. So I just pulled in the function body back. So that's not a change, of course. So I know that user disks are not mounted if there is no machine config. So an easy fix here will be to test if the machine config is nil, do nothing. Don't have. So now, like rinse and repeat, basically. We're doing the same process over and over. Building an ITRAMFS, which takes more time actually than anything else, and rebooting VMs and trying once again. And hopefully one day we will get to the shutdown sequence. Yeah, there's a comment. I don't know if I can actually do a chat overlay. That will be more fun or not. Okay, I can at least, I guess, show them. The CRI bug was a feature to hide all these panics. Yeah, exactly. It was rebooting instead of shutting down, but also hiding all these panics. That's exactly that. So I got new initramfs built. I'm going once again, same process, rebooting all VMs. Here I'm waiting for them to boot back so I can. Okay, it's back, so I can connect to the monitor and try same thing. Send the power down event. We have more panics. That is cool. Now we have the unmount system disk bind mounts task, which is once again in the same file. You can see like lots of stuff in Talos is in that file. That's the sequencer. There's another part of Talos we are not touching today, controllers and resources. But yeah, this sequencer part is fun. So we have this line 1369. Let's look what's there. 1369. Well, it's same issue more or less, but this time a bit different. This task tries to unmount what is called like a bind mounts for Talos system disk. It's more or less about /var, but the thing in Linux says that you can mount /var, and Talos does that initially, and this mount will look like mount from dev SDA like 5 to /var. And then once it is mounted, you can do a bind mount of anything under /var under a completely different directory. And after that, you can unmount /var, which is interesting. And if you look at the mounts, there is nothing which holds your block device like SDA. You look, nothing is mounted from dev SDA. But these bind mounts, they still exist. And as they exist, they actually hold this partition. So if we try, for example, to like repartition the disk or resize the partition, something like that, this will fail because it's actually mounted. So what this task does, it tries to find all these bind mounts which are actually referencing that device and unmount all of them. So we need to, and for that, it tries to figure out where it is itself. Where is the system disk. And in maintenance mode, Talos doesn't have a concept of a system disk because system disk in Talos is defined as the disk which has the ephemeral partition. And well, it might have actually a system disk in general. But in my case, I'm testing the worst case scenario, probably the one when there is Talos is not installed. So it doesn't have a system disk. So it can be like it can't find it. So it's basically should be nil in this case. So the next question is to see what this whole like thing returns when there is no system disk. So I know like state and machine, these like first functions, they never return nil, but there is this disk function, and that's a function on the interface. So I need to find implementation. So I can do go to implementations, which is nice feature with the Go language server. And I have this implementation of this function. So what it tries to do, it does some preparation, says that the system disk is the one which has the ephemeral partition label, blah, blah, blah. Then it does this probe disk call, which goes over the disks and tries to find that disk and has some logic. And it also, if that disk is already probed, it will kind of return early. Not really like interesting, but the point I was getting to is that if there is no system disk, it will return nil. That's what I was getting to. So that is the important fact for me. So what I can do something like this. I'll split this call a bit and in two steps. Here I will check. So if system disk is nil, I don't have to do anything because there can't be any bind mounts of a system disk if there is no system disk, obviously. It will be a shortcut for me. And once again, I'm now lost track of how many panics we had. Is it the fourth or the fifth one now? But let's see. But our goal is to go get a clean shutdown in maintenance mode. Then we'll test things in normal mode that we haven't broken anything. And also we had an issue in normal mode when I did the shutdown kind of early. There was a different error which showed up. I'm not sure if we have time to fix that today on this stream, but anyways, we'll create an issue for it. Okay, rebooting all VMs to get latest Talos. Okay, it's ready. So now I can try shutting it down. Probably I can automate that completely. But okay, next time. Wow, finally. We have a system halt. So, which means, like I said, in my case, as I'm running this in QEMU, it has a special flag to actually, instead of power off, to do a halt. And the reason is, it's a bit twisted explanation, but when we run QEMU, what we are doing is that we try to be smart and try to detect whether Talos is installed on disk or not. And depending on that, this Talos CTL wrapper can either boot QEMU from kind of network quote unquotes, like the initramfs I have, or it can boot it from like its own disk. And for that, it needs to know when the machine gets rebooted. So it starts QEMU in a special mode when QEMU quits, like quits the whole process when it reboots. And like there's no power down in QEMU technically. So when it powers down, it actually quits as well. So for Talos, then the power down would look like a reboot, and it will like boot the machine back. So we will be able to see that it kind of powered down. Like you try to power it down and keep on it just boots back up, which is not fun. So we tried to do this hold, which means that it's the CPU hold. So it's not like a real power down, but once again with Kimo, there's no real power down because it's just a VM. But anyways, we did a bunch of fixes, and like I said, we need to test that in normal Talos mode as well. And there are like few questions I always try to ask myself next. First of all, I would like to see what are my changes, right? And okay, here I fixed the dbus. That's a bit of a refactoring. I moved the code inside, but the meaningful change was checking for config being nil. Check for like system disk being nil. And here I did a check for CRI running in somewhat. These are meaningful changes to me, and I think these bugs might pop up not only in maintenance mode, but also in case when Talos is not fully booted up. So these things make sense for me. The question I'm asking myself, okay, how would I prevent these bugs from appearing in the future? So I would probably need to run a test for it. Can I run like a unit test for it? Probably no. Well, I mean, I could, but whether it will be of any value, because it's what I'm looking for is the exact like sequence of things happening in Talos running, and that's not a unit test, right? That's not a single component which I can easily write a meaningful unit test for. So I'm probably looking for an integration test for something that I was doing right now manually, but to be automated. And then I hit a bit of a wall because I know Talos has integration tests, like a wonderful test suite, but it never tests Talos in maintenance mode, unfortunately. So if I want to have a test suite for specifically maintenance mode, I probably need to write another test suite, which doesn't seem to be that it would fit into the the time I have for this live hack session, and I would rather finish that with something meaningful. So I would rather create an issue to do some integration testing in maintenance mode. Doesn't have to be crazy, but it does make sense, I think, to run some tests in maintenance mode. But also, I would like to run the linter to make sure that my code changes are fine. We have lots of automated checks for code. So sometimes the linter might find some real issue with my changes. Sometimes it might be more about like styling, white space, whatever, things which don't make any difference, of course, to the code itself, but still they enforce consistent styling of the code. Okay, I haven't run the linter for a long time, so it doesn't have the cache, so it will take some time to lint the whole Talos code base. But while it's running, the next thing I would like to do is to test the shutdown in normal mode to make sure that nothing is broken with my changes. And there was one more failure we saw in the beginning when I was doing the shutdown in normal mode, but kind of early in the boot sequence. And that failure was totally, was it really different or not? Hold on, which failure it is? Seems to be the same one to me. Now looking this, it said here, failure connecting to the CRI, which is kind of same. I think I saw another error there. Oh. Yeah, I probably looked at this message, but this is not fatal. It just means that kubelet is not running. Actually, yeah, I kind of missed the actual error. That is the same error connecting to CRI. That's the same I saw in maintenance mode, so probably that is fixed. That is when I hit the shut down while the node. There is a question. Should not have linter found those missing nil checks? Well, I wish it was that smart. Like in Go in general, this like nil pointer problem, I would say, is not fixed. Um there's no like real fix, and many like any pointer in Go technically can be null. So if someone would be checking for every pointer everywhere to be null, the code would look like crazy. So probably Go needs an answer for that, more like a Rust way, um, or some other way. So I agree that's kind of a problem. So that certainly putting a nil check everywhere doesn't make sense. Probably what makes sense is in general to have the what we have is we have a sequencer which runs some kind of a sequence, which is basically a sequence of like actions or functions. But there is a startup sequence. I'm simplifying things a bit, but it doesn't matter. There is a shutdown sequence, and those are not in sync. I mean, like if the startup sequence was aborted, like 3 steps into it, the shutdown sequence will still run all the steps. That's why we have like some shutdown steps which run and fail, and the only reason they fail is because they depend on some startup step which never ran, right? So they're not in sync. That's the core problem. Yeah. Okay. So let me see if linter came back to me. It should. Yeah. Okay, I have no linting issues. So technically I can submit a PR right now to Talos and get it reviewed. So it should be fine. I hope I haven't broken anything else. But let me do some more manual testing. And what I'm going to do, I'm going to destroy my cluster, which was sitting in maintenance mode, and instead create the cluster in normal mode. I'm removing these flags, keep injecting config, so that the cluster will boot up successfully. And first, let me like wait for it to fully boot up, become completely ready, and then I will try to shut it down. That's the happy case, but I want to make sure that it works because it has all like basically has all the steps it needs to do to shut down the node, and I want to make sure that these steps are still running fine. But I think in general, these panics is that we are writing the code with some, we're humans, we're building some assumptions which are only in our brain. We think, okay, if I have a start function and a stop function, then whenever stop gets called, someone should have called start before that. Hey, that's not always the case. That might not happen. But like in our brains, we have this model, I guess, some kind of model that say, yeah, start should have been called, but no, it's not. Okay, so Talos is booting up like a normal mode completely. We see the logs scrolling at the lower part of my screen. That's just normal startup. Talos is now bootstrapping Kubernetes. Like all the components will should get running, and now we have API server running because I saw it creating the bootstrap manifests. And right now, probably controller manager, well, wasn't running because kubelet got the cert but couldn't register itself. So it usually means that controller manager is not yet up. But now everything is up. The nodes are registered, and we see that Talos is waiting for the node to be ready, which most of the time means just waiting for the CNI to be ready. It takes a bit of time, but should be there anytime soon. So the worker is fully ready from Talos' point of view, and the control plane is. The health checks should notice that as well. Now the remaining health checks are more like Kubernetes focused. It's waiting for the pods to appear in Kubernetes. I don't care. Like from Talos' point of view, everything is booted up. It will appear in Kubernetes, but not important for me right now. So I'm just cancel that. I'm doing the same thing, going to the chemo monitor and trying to send this power down event to the worker. And here in the bottom of my screen, it received this ACPI event and successfully shut down. But I will like scroll back through the like stages of this sequence to make sure that. So first thing, I haven't changed that. It's shutting down the kubelet gracefully. It's using that dbus interface we were fixing issues with. Now it's actually running because the kubelet is running. Yeah, I like this comment about stupid computers. So we have these like stop all pause. We're shutting down the kubelet. We're waiting for it. We can see that the kubelet was actually shutting down things because after that we can see kernel messages about CNI interfaces going down, which is expected when the pods are being stopped. So we know that kubelet was actually running the shutdown sequence. Then it got back to us pretty quick in 5 seconds and said, "Okay, I'm good." So the Talos stopped the kubelet itself, and after that, it got to stop the remaining workloads. Um, it says like stopping stopped, but I believe it doesn't do that. Kubelet already stopped all of them, but Talos tries to be like extra sure to stop everything as well. So we stopped all pods, then we stopped dbus. It's no longer needed. Kubelet is gone. We're stopping some services. We haven't touched that path. We said unmount user disks. Well, it's kind of no op for me right now because I don't have user disks. I can actually test with them as well. And then system disk bind mounts, and you can see it actually unmounted something, which is cool, which means that this task is working. And it unmounted like /var. It found some more bind mounts. Cool. And I believe after that we had no issues, but it's stopping everything, waiting, all good. And in the end, what Talos tries to do is it tries to unmount everything which is still mounted. And there is nothing there. It like unmounted slash, which for Talos is actually squashfs coming from an itrmfs image. That's fine. It's actually read only from memory, and this is also squashfs. It's the way it runs the container for APID. Yeah, you noticed that message about failed Unix reboot. I was looking at that. That should be just like, well, it's not a real message. Well, I mean, it's like a real message, of course, but it doesn't look like a real sign of the problem. But this Unix reboot and this weird value is actually coming from Linux, and Linux has these constants. There's like a reboot syscall and different constants which say what kind of reboot would you like a normal reboot, would you like a kexec based, and shutdown I believe is also like a form of reboot. So this constant is probably this halt that we are doing, because that last system halted is printed by the kernel. It's not Talos printing this. So we can try to fix that, but I think that's more of a birth dates of Linux kids. Yeah, pretty well might be, even though CDEF 0123, well, might be, but looks like a looks just a random, well, not random, they're just consecutive uh, numbers, right? Okay, let's look into that. In many places, and so okay, then probably to finish that explanation, when we do a reboot or shutdown for Linux is same as a reboot. What we're doing, we're returning an error, a special type of error, which means that we want to stop running sequences, and inside that error, we encode what is our intention, what we would like to do, like this Linux constant, which says whether it's shut down or reboot. That's why it looks this way. So if we go to the shutdown task, which will be once again in these sequencer tasks, shutdown task, you see it's like defaults to this power off constant. But if it's hold, it uses this constant, which is exactly what we saw there, CDEF 0123, takes that constant and returns an error. Well, it's like a go error, but we treat it like as a signal to kind of abort, but not really an error, and embeds that inside that error. It embeds uh, the actual constant, which kind of reboot you want. That error will be caught by the very machine D main function, which is like grabs the whole Talos PID1 thing, and it catches that error. Okay, I need to reboot, so it will just call after unmounting everything, preparing everything, it will call that final syscall, which will basically will be the last syscall that we're doing, because it's going to stop the system, either reboot it or shut down. But really, what happened is that error got to the code in the sequencer, which printed that message to the console, which doesn't look nice. We shouldn't be saying this failed to run. Failed to run, then shutdown is the name of the sequence. So I think it might be. I don't want to print that message ever, actually. But let me see. So fail. Where are we printing this even? Failed. Oh my. Failed to run. Not many matches. Failed to run. Oh, hold on. That's a separate one. Failed to run shutdown sequence. That's actually the message we are printing, specifically in this ACPI case. And we shouldn't be printing anything if we get this error. So I was thinking it was even like somewhere deeper, but it's not. So we can check whether this error is of a specific type. And if it is, we can basically just skip printing this message, because we know it's kind of an expected error, and that's fine. So we need to define this runtime, what it was, runtime reboot error. We need that's the way to do that. And I always do this wrong. It's a bit, I think I even need to make this a pointer if I remember correctly, but let's see. If it's not this, we log the message. So if it's not of that type, we're going to log the message, and let me check that. To the value pointed to by target. Oh my God. That's always hard to understand, but I believe the linter should help me with this. And try to run the linter and see. I believe it complains if I do it wrong. Always miss how many this as probably needs to be re-implemented with generics. It will be much easier to consume. Because these pointers to pointers is really okay. Linter didn't complain, so once again we're back to our test cycle. We're building an InitramFS. We don't need to recreate the cluster. The cluster is now running in normal mode, so it has everything installed on disk. So I can just simply reboot all VMs. They will boot back into normal mode much faster than the initial cluster creation, because etcd is bootstrapped, Kubernetes is bootstrapped, all the data is in etcd. I can just simply do a quick reboot of all of them, and they should pretty quickly boot back up with like in fully running mode. So let's see. we have new initramfs, so we're going to reboot all VMs. It's kind of doing like this hard reboot, not a graceful one, but as I'm doing development, I don't care much. Of course, not good to do that for real nodes, but I don't have any data in my test cluster, so it's booting back up. It will take a bit of time for API server to come up, and you can see some errors now printed because the control plane, we had a single control plane node and that got rebooted, so it will take some time for that node to be up. And you can see control plane is up and worker is also going back. Yeah, booted back up. Like, I think it's not bad. It's like 30 seconds to get back up completely. And now back to my testing. System power down. Yeah, I got things wrong, looks like, because I see the same message printed. But this might not be that simple as well. And the reason is that if you look at this error message, it's kind of a long one, really. And so this message, this error was wrapped multiple times before it got there. And if the way we wrapped that was correct, then we can still use errors as to test for a specific error type. But if we did it wrong, we wrapped it at some place wrong, like, and then there might be that we can't match that against the type of this inner error. That's what we're looking for. So we probably need to do like a quick check. And also I might have got this incorrectly. I think I got it correctly, but let me check once again. And so we're returning this by, yeah. So that's the reboot error. We're returning it by value. That's how it prints itself. That's what we're seeing in the error, which, yeah. Oh, we have a, yeah, I got it wrong. We have actually had a helper uh, to do this check, which is nice. Looks like I also already hit this problem. So let me, if not, runtime is reboot error. We'll make it a bit more short. It's nice. I think I can put it here as well. That's really similar path, which handles seek term, which can't really happen when you're running Talos in a real machine, because init process shouldn't get seek term ever. But when you're running Talos in a container and then init process is like PID1 of a container, and so PID1 is this container first process. When you shut down the container, that's what it gets, this seek term. So that's will be shut down for seek term. So that's kind of a container mode, really. But let's make it nice both ways. So let's see if that fixes it. Okay, we have some more comments related to these reboot constants in Linux and being the birthdays of the Linux kids. That is nice. Nice way to remember when your kids were born. Okay, we're over 1 hour now, and I think we should probably wrap it up soon before everybody gets too tired. So we're doing almost same thing over and over again, building an intro and fast rebooting Talos. But yeah, that's more or less how you're doing Talos development sometimes, because you need to do lots of testing. And so we were trying to fix that error message, which was harmless but confusing because nothing actually failed. It was a successful shutdown. But that message just before the power off was confusing. I hope nobody can actually see that with the real machine, because it will appear just before the power off, but still doesn't look good to me. Okay, it's halted, stopped everything. Oh my god, I just pasted some lines, so that shouldn't be there. You can ignore the last line, but we don't have any error messages anymore. So I got now things are right, and what we're seeing is that the pods are migrating to the control plane node as I shut down the worker. I guess that's why we see them popping up. I guess it's core DNS going to the other node. Okay, power down is working. So what else can I do? I can try to do what failed for me first time, is trying to power down the node while it is booting. So let me wait for Talos to start, and now power down. Well, it was fast, but I think I saw it successfully halted. Let me scroll back to see where we are. Uh, so we were really early into the boot sequence, like we're trying to run UDFD, and we kind of got the shutdown there, which is fine, I think, and we have a clean shutdown here, which sounds good to me. I think we fixed everything we could, and the changes seem to me like quite harmless. So once we do some more testing in the CI and we get proper reviews, we can actually look into backporting this change to the stable Talos release 1.3, so we can get this fix back. But it will certainly be in the next version of Talos. So I'm going to, well, let me pull to see if there were any PRs merged to main. No, so I can create a branch and I can call it something like that. Fix ACPI shutdown already exists, so I worked on something like that in the past. So I'm going to write a commit message. So I can make this full screen. So we're using this, like, I forgot how this is called, but commit messages which have a structure. So it starts with the with either like a fix or a feature. That's certainly a fix. We're fixing a bug. We can say ACPI shutdown in maintenance mode. We can link it back. Yeah, conventional commits. Thank you. We should link it back to the bug we're fixing, which is 6817. 6817, and should do some nice description. The original problem wasn't reproducible with main, and let me try to, I remember I fixed something somewhere there. I want to see if I can cross-link that. That's kind of not really, just to make sure that, because there was a change I did somewhere to this maintenance mode service, which made it actually abort, I think. She made it abort. She made it abort. But where was that? So it was in sequencer, we have this. I lost that. I have this load config, and it's a very confusing function. It's very long one. Somewhere in this function, we are getting into this maintenance mode. Yeah, I think it happens here. We go into fetch config. No, yes, this receive config using maintenance mode. That should be it. We run the maintenance service here. That doesn't look to be that. Maintenance run. There was something here. Yeah, okay, I can't find it this way. I was hoping I could find something in the code. But let me use git log because I don't remember. Git log internal. There was some kind of a change I did for some different reason. No. Fix always abort the maintenance service. I think that was it. Looks that very familiar to me. Okay. Let me go to GitHub and try to search for that. Well, it finds the pull request by the commit ID. That's nice. Well, now I'm not positive that it's, but probably, yeah, that was it. Okay. 6, 1. But no, that can't be that. Okay, now I'm not going to spend much time on that. I will get back to that. But that can't be that fix. There should be something else. So the original problem was that it was like sequencer locked, but there was a set of bugs in the shutdown sequence, which was preventing it from completing successfully, as in the maintenance mode nothing is running and initialized yet. Most of the bugs were nil pointer dereferences. Okay. Fixed small issue with final reboot error printed as a failure in the ACPI shutdown path. Oh, that's okay. I have the git commit. I signed that, and I'll push that branch back to my fork so I can create a PR. Can create a PR here, And I think we have today some issues with our CI, so I won't be able to proceed much further with that. But I'll create a PR. I will assign it to the current milestone, which is 1.4. I will pin it to our projects we use to have a board of active issues. And I will also pin it to a project which collects all the issues I would like to backport. I'm going to create this pull request. And once it gets reviewed, it passes through the CI through all the integration tests we have. And what I will do, I will create follow-up issues to have some tests for maintenance mode. And it says that, oh, it already failed. And that's because of the check, conventional commit check, that the first letter after this fix should be lowercase. Probably I need to rewrite the commit message. Oh, hold on, that's a different terminal. I'm lost in my windows now, which one is which, but I'm going to rewrite the commit message. Okay, that should be enough to get it unblocked. Okay, that should be it. That was a long session, almost like an hour and a half. We got something achieved. We fixed several issues in Talos, many more than I thought we would fix. We had a PR. We talked a bit about the development cycle, building Talos, rebooting that, testing things, how to do ACPI shutdown with Chemo, how to run Talos in different modes, and we tested all these things as much as we could. Like I said, the maintenance mode test, that's something we need to implement to make sure that maintenance mode runs correctly, because our current tests are running against like a normal mode. So maintenance mode tests, they deserve a special test suite to make sure we test that. But that should be it. Thank you everyone who got to this point, and see you next time on the next hack session. Thank you. Bye. Thank you once again.